Hello, welcome to this episode. Last time we were talking about the different types of fractions and how we can convert proper, mixed, improper into decimals. Now in this aspect, I just want us to look at this exercise, okay? At least it will help us. So when they ask us to write the following as decimals, number one, we can either use the long division, and alternatively, we can just use the calculator straight away. Okay, so let's say we are using the long division. We have 2/3, which means it's going to be a 2 here and a 3 there. Okay, and then from that, we don't have any 3's in 2, so it's going to be a 0. We put a comma, we introduce a 0 there. So how many 3's are in 20? We have round about 6. And then 6 times 3, we get 18. You subtract that, you get a 2. You put a 0 again. So it's just going to be a repetition. So it's a 6, 18, 2. Then it's a 20. And so which means that this number is just going to continue. And so on. So it's going to be a 0,66666 non-stop. So I would rather say it's a 0,67 if I round it off to 2 decimals. And then if I have 3/5, okay, so with the 3/5, I can still use the long division, okay, or I can change this denominator into a 10 by multiplying this by 2, multiply that by 2, so that I have 6/10. Then 6/10 is the same as 0,6. Alternatively, if I use my calculator and say that it is 3 fraction 5, I press the equal signs, and then I press this SD button, I will get the 0,6. With the first one, the 2/3, if we use the calculator, 2, we have 3, the equal sign, we press the SD, get 0,6, recurring, so it's a repetition. And then the next one, it's 5/6. Let's use the calculator. It's 5/6 equals, it's going to be 0,83 recurring. Okay, so I'll just say this is a 0,83 recurring. And then 3/4. Let me just use a calculator straight away, but alternatively, we can change this into an improper fraction. So it will be 3 times 4 plus 3/4. So that's a 12 plus 4, which gives us 15/4. So let's punch here and we see 15/4. So 15/4 equals, we're getting 3,75. Okay, so it would be the same thing if somebody was to use the long division. You're still going to arrive at the same answers. Okay, and then question to write the following as fractions. So whenever we're writing as fractions, we look at the decimal place or the place value. So if I have 1, 2, 3, 4, 5, 6, we say that 3 is represented by the units, 2 is the tens, 1 is hundreds under the place value rules. And then the numbers after the comma, the 4 will represent the tenths, 5 represents the hundreds, and then 6 represents the thousandths. So what this means is that tenth is the same as 1/10. Hundredths is the same as 1/100. Thousandths is the same as 1/1000. So we just need to look at the place values and then decide. So when we look at the 5, which is the last digit, it's representing hundredths, which means I'll get the number 25, I'll divide it by 100, and then I'll simplify that fraction. So if I have 25/100, it should give me something like a quarter. Okay, that's 1/4. So this becomes the simplified fraction. And then if it's a 0,3, so place value of 3, is 10. So it's going to be 3 over 10. There's nothing to divide 3 and 10, so we leave it like that. And then if it's 1,45, we shall say 145. This 5 is 100, so over 100. Alternatively, look at the numbers after the comma. If it's just one number after the comma, you divide by 10. If it's two numbers after the comma, you divide by 100. If it's three numbers after the comma, you divide by 1,000. So 145 over 100, we see there's something common. 145 over 100, we can use 5. It's 29 over 20. So 29 over 20 is our answer. We can change this into a mixed fraction. So how many 20s are in 29? 1, remainder 9 over 20. And then 2,6 is going to be 26 over 10. We can divide 26 and 10, which is going to be a 13 over 5. Okay, so that is how the conversion works. Then when we talk about percentages, so one thing we know about the percent, this is a special ratio. Okay, it's a ratio in that it's over 100, regardless of what is on top. Okay, so it's a special ratio, a special fraction that is over 100. So we use this symbol to represent percent. Okay. So if someone tells you that we have 5%, so that's the same as 5 over 100, meaning that for every 100, there is a 5. If we have 33%, they're telling us it's 33 out of 100. Okay. Now, we can change the percent into decimal by just getting 33 divided by 100, which becomes 0.33. And alternatively, we can also move from these decimals back into the percentages. All right. We have some examples. They're telling us that Tim would like to buy a bicycle that costs 1.2. The grandmother is prepared to give him 40% of the price as a birthday present. How much is the grandmother going to give him? So 40% of 200. Okay, so 40% of 1.2. So that's going to be 40 over 100 times 1,200. We can say over 1. Multiply the top, multiply the bottom. So that's going to be 48,000 over 100 times 1, which is 100. These two zeros, cancel those two zeros. And then we end up with 480 as our answer. If you have question 2, this person receives a commission. So commission is something extra you get, maybe because you made a sale or you impressed somebody with the way you are doing your things, meaning that for every sale, in most cases, it's the salesman. For every sale you make, you're going to get a small percentage. Cut. Okay. So there's a 2.5% on the sales. The monthly sales for December were 175,000. They want the commission. So it's 2.5 over 100 multiplied by the 175,000 over 1. When you punch this in the calculator, it's going to be 2.5. We can use the percentage by the symbol on the calculator. So it's a shift and this open bracket. Okay. And then we multiply it by this 175,000. Okay, what does that give us? 4,375. So it's a 4,375. So this is how much this person will receive for December commission. Number 3, they're telling us that Kate bought a dress that was priced 1.8 at some boutique. Okay, she was given a discount of 30%. How much did she pay for the dress? There are 2 ways to do this. Number 1, we know that the original price is 100%. Okay. Now, if we subtract 30% that you're not going to pay, okay, 100 minus 30, which means you're going to pay 70% of the price. So it could say 70 over 100 multiplied by the 1.8. Let's see. So we said 70%, which is 17. I'll use the percentage symbol, okay, multiplied by 1,800. I'm getting 1,260. So you need to pay 1,260. So this is one option Alternatively, you can get the discount just the way they are doing 30 over 100 times 1.8. Okay, that's going to be 54,000 over 100. These two zeros cancel that, you have 540, and then you have to subtract. And then you still get 1260. The number 4, James received an increase of 1.2 per month on the monthly salary of 9.6. Can we determine the percentage increase? So what we notice is that, okay, so for us to get the percentage increase, so we already have the increase that they gave us, which is 1.2. We're going to get 1.2 over the 9.6, multiplied by 100 over 1. Okay, so that's going to be 120,000 divided by 9.6, because when you're multiplying, it should be across. Okay, let's use our calculator. We're saying 120,000 over the 9.6. It equals getting 25 over 2, which is 12.5. So meaning that the percentage increase is 12% or 12.5%. All right, then number 5, if you obtain 12 out of 15 for your first assignment, what is your percentage mark? So the smaller number, 12 over 15, multiplied by 100 over 1. Multiply the top, that's 1.2, multiply the bottom, which is a 15. So 1.2, we are dividing it by 15. That's going to be 8. So you achieve the distinction, which is 80%. All right, so that is how the percentages work. Okay, there is another one here for the discount. So Joseph bought a TV set that is normally costing 2.5, but for just 2,000. They want us to get the percentage discount. So what normally happens is that we get the new price minus the old price, divide by the old price, multiplied by 100. So as long as you're looking for a percentage increase or a percentage decrease, this is the way to go. So our new price is 2,000. Okay. Our old price is 2.5. And then the old price is 2.5. And then you multiply by 100. Now, the difference between a percentage decrease and a percentage increase is the negative sign that we attain. Okay, so here we're going to have a 2,000 minus a 2.5. Okay, we are dividing by 2.5, and then we are multiplying by 100%. Multiply by 100. This gives us minus 20. So it's a negative because it is a discount. So that's going to be 20%. Okay. Okay, so if ever it is a percentage increase, in most cases, the answer we get is going to be positive. Nevertheless, whether it's an increase or discount, must always remain just as a positive result, but just for cases of calculation based on the formula. Okay, let's look at this exercise. We can do it together. Let's see. Okay, let me just get a blank page that I might need. Okay. Let's just increase it a bit. Okay, that's better. So Sarah bought a box of apples. Okay, we had 125 apples in the box, and then she discovered that 4% of them were rotten. So how many could she sell? So I mean, 4% of them were rotten. So you cannot sell the rotten apples. Okay, so that's going to be 100 minus 4, which is going to give us 96% of the apples that were right or good. So we can say that 96 over 100 multiplied by 125 over 1. Let's punch that in the calculator. So we are saying 96%, okay, times 125. So what we get? We get 120 apples. So that is 120 apples that she needed to sell. Alternatively, you can get 4 over 100 multiplied by 125. Okay, let's see. We are saying 4% of 125. This must give us 5. So 5 apples were rotten. Then to get what is left, the good ones with 125 minus 5, which gives us 120. And then number 2, Peter's monthly salary is 9,000. An amount of 3,150 is deducted for income tax. Can we determine the percentage that he pays? So the 3,150 over the 9,000, we're going to multiply it by 100, meaning that whenever we want to change anything to a percent, we have to multiply by 100. Okay, let's see. 3,150 over the 9,000. Okay, and then we are multiplying this by 100. We get 35%, which is a very big percentage for tax. Okay, and then question number 3, a survey reveals that in a small town of that place, 4150 families out of 11275 families own DVD players. What are these? I mean, they are old models. Okay, they are dead. What percentage of the families do own? So we're gonna get the 11275. No. It's the other way around because they told us 4150 out of own. Okay, so it's going to be 4150 over 11275 times 100. Okay, so it's 4150. We are dividing it by 11275. Okay, what do we get? By the way, we have to multiply by 100. Yes, so let's multiply by 100 first before we change it. So this becomes 36,80. So these numbers are repeating. So let's just round it off. So 36,81. Okay, saying 36,81%. And the number 4, Mary bought a pair of shoes on which she had to pay 14% VAT. Well, it's currently 15. Okay, so determine the price of the shoes. So she had to pay 14%, meaning that there's an increase. Okay, so if the shoes were being looked at 100% as the normal price, now when you increase the 14%, it's going to be 114%. So it's 114. We can say over 100 multiplied by the price of the shoe without VAT, which is known as the VAT exclusive price. Okay, so we need the VAT inclusive. So 114% multiplied by 216,6, we get 246,92. 246,92. So this is how much she's gonna pay in the shop. The number 5, the price of a loaf of bread currently is $5.12. This was way back, maybe in the 1990s. Okay, it increased by 9.5%. What is the new price? So still, we can do the same thing. This 5, what is at 100%. Now we need to plus the 9.5, which means going to be 109.5%, which is 109.5 over 100 multiplied by the 5.12. Okay, let's see. 109.5, we shall say shift and that button percent times the 5.12. What we get? We are getting 5.60. 5.60 rand. So that's how much the new price is going to be. Alternatively, remember we said we can also have 9.5 over 100 multiplied by the 5.1. Get the answer, and then you plus the 5.1. So this could be something like a 0.4 or 38 or somewhere there. All right, we move on to the ratios. The ratio, the thing is that the ratio is the way of two or more quantities. okay? But there is a condition that is missing. Quantities of the same units, okay? In other words, the units have to be the same for you to do the comparison. So suppose we have a pupil-teacher ratio, which is a 40:1, okay? Teacher-pupil, those are human beings, so the unit is the same. Okay, then we can symbolize, or we can symbolically write pupil to teacher as 40:1, which is the same as 40/1. So how do we read it? It's 40:1. These two dots will be 2. So for every 40 learners, there is one teacher. So the order in the ratios is very, very, very important, okay? Because whatever is mentioned first must come first in as far as the numbers are concerned. Okay, so if it was the other way around, let's say teacher to learner or teacher to pupil, then it was gonna be 1:40 because it creates a lot of meaning for as long as the order is followed. Here is an example. Okay, Albert has 10,000, which he wishes to divide between the two sisters. Okay, Alice and April in the ratio of 6:4. How much will each one be? Now, what this question is talking about is more like, how do we divide in a particular ratio? So the process or the procedure is very simple. Number one, you need to get the total ratio. Okay, so in this case, we're gonna have a 6 plus 4, which gives us a 10. Okay, I prefer now to get the amount that is going to be shared. We divide it by the total, meaning that it's gonna be the 10,000 divided by the 10, which gives us 1,000, meaning that every one part of the ratio is going to be representing 1,000. Meaning that since we have Alice and April, so Alice is gonna take the first ratio, which is 6. It's gonna be 6 multiplied by what each ratio part is, which is 1,000. That gives us 6,000. And then when we look at April, the ratio for April is 4, which is gonna be 4 times 1,000, which becomes 4,000 rands. Okay, so at the end of it all, when you plus these two, you should be able to get back to what was being shared. Okay, so that is the process. Get the total ratio, then divide the amount by the total ratio, and then do the multiplication. Alternatively, as the study guide is showing us, the portion that they will receive, then the total portion, and so on. So they added up, and then they divided that. For Alice, it will be 6 out of the 10 portions that she'll get. Multiplied by the total amount, you still get the 6,000. For April, it's the same thing. 4 out of the 10 multiplied by the 10,000, it gives you the 4,000. All right, question number 2. Jerome picked 7 apples, and he wishes to divide them between Sipo and Simon in this ratio. Determine how many apples people will receive. So get the total ratio, which is 3 plus 8, which becomes 11. Okay, then we divide. So 7 divided by 11, meaning that it's 7, meaning that every part of the ratio is going to be 7 apples. Then the first person was Sipo. So Sipo is going to be 3 times 7, which is 21. And then we have Simon, that's going to be 8 times 7, which is 50. And that is how we do it. But then the question was, how many apples will Sipo receive? Did we do anything wrong? That's 11, that is 7. Okay, so it is 21. Okay, yeah, 21 apples. Okay, then this exercise, we look at it and telling us we have 7 Smarties in a packet that's containing red and green. Smarties are in the ratio of 5:3. So 5 is for the reds and then green is for the 3. Determine the number of red Smarties in the packet. So get the ratio, which is going to be 5 plus 3, which is 8. And then what is 72 divided by 8? Let's see, let's consult the machine. 72 divided by 8, this becomes 9, okay? So meaning every part is a 9. And then for the red smart, it's gonna be 5 times 9, which becomes a 45. Okay, look at number 2. The ratio of stone, sand, cement in a concrete mixture is 6:4:1. Okay, determine the percentage of stone, percentage of sand, percentage of cement. So let's get the total here. We know that 6 plus 4 is 10 plus 1 is 11. Then for stone, okay, stone comes first. It's going to be 6/11 times 100, since we want the percentage. For the sand, it's going to be 4/11 times 100. And then for the cement, it's going to be 1/11 times 100. Okay, let's use the calculator and see what kind of answers we end up with in this regard. Okay, so 6/100, so say 6/100. No, 6/11, sorry. 6/11 times 100, which gives me 54.54. Okay, percent. I'm gonna keep it to decimals so that we end up with the same accuracy. Then 4/11, okay, times 100, since we want a percent, that's going to be 36.36. Okay, that's a percent. And then lastly, we have 1/11. We are multiplying this by 100. What this becomes is 9.09. I don't know if that makes sense, 9.0909 and so on. All right, so that is how we were going to have it. I know when you plus this up, they could have just a difference of maybe point something, okay, which we can really cater for. Okay. Now, that is exercise 3.7. Now we have the next page. The next page talks about chapter number 4. And in this chapter, it's more about the measurements, okay? So what they're telling us that within this chapter, there are things that we need to understand or we need to get to know. Number one, we need to know how to convert the lengths, okay? Remember, whenever lengths are measured, they are units like kilometers, centimeters, or meters. So we need to know how to convert from one unit to another. We need to find, or we need to know how to find the perimeter of the different figures. We need to know how to calculate the area of different figures, how to determine the volume of the different objects, and how to convert liters to cubic units or cubic units to liters. And then how do we do the application into our day-to-day lives, okay? So measurements as a topic is widely used across nature, okay? From traveling, okay, you're moving distances, you're moving at speeds, you're moving at all of that, okay? Back into the kitchen where food is made. I mean, measurements need to be taken when you're baking. You must mix a certain number of cups and all of those things. Okay, so have you ever renovated the tiling of a bathroom kitchen of your home? No, have you ever witnessed one? If yes, then you'll know that in order to do that, you had to decide how many tiles to buy. Were you able to determine the number of tiles? Or, you have to ask somebody else. And so we start off by showing the basics of measurements, okay, that will enable us to tackle problems that are similar to the ones that have been described, okay. So first things first, we have what we call the international system. So sometimes this international system is normally abbreviated as SI. System International in the Latin version of it. It is difficult to imagine a world without a system of measuring things. You would not know the distance to another town, the capacity in liters or fuel in the tank, whether your body mass is within the limit or not, okay? So in the early days, measuring was done, okay? They're telling us that the measuring system originated from the barter system, or the units that corresponded with things like length or size of a hand or a foot, okay? That's why in most cases, when they say someone's dead, they're gonna bury them 6 feet. It just originated from back then, okay, that measurements were done using mainly the body parts. Okay, we have something like cubits when you look at the length of your hand to the ankle or something of the sort. Then many countries each had their own way of measuring things, even time. They would just look at the sun and the position of the sun and tell that it is maybe 12 o'clock, or it's 3 o'clock, and up until the normal clock was invented. So in the modern world, which is characterized by international trade and extended industrial and technological development, it was vital for us to have something that is common. And that common thing is what we are calling the international system or system international, the units, also known as the SI. This was developed, and South Africa was one of the first countries to accept these systems. Now, what we mean by the SI is that this is a system that is recognized internationally. When you go somewhere and let's say you want to measure the length of something, there's a particular unit you use. Okay, when you want to measure the capacity of something, there's a particular unit that we use. Now, we have, okay, which is 10 to the 1, we just call it 10 in the decimal system, but in the SI, this 10 is known as a deca. Okay, if it's 100, which is 10 squared, it's the same as the hectare. We use small h. Deca is capital D. And then if it's 1,000, we use kilo with a small k. And then if it's a million, we use mega, okay, with a capital M. And then for smaller units, if it's a 0,1, which is 10, we call it a dec. If it is 10 to the 2, we call it a cent. And then milli as well as micro. Okay, this is all we need to know. So what this also explains to us is that under the systems of measurements, remember, we have what we call the metric system, and then we also have what we call the imperial system. So the metric is normally used in Africa, okay, countries that were mostly colonized. That's where that system works. And we have 7 units under the metric system, and we're just gonna use more or less the same thing. So if we are measuring, let's say, length, the unit for length is usually meters. So with the 7 units, we have king, held, died, many, dogs cried, much. Okay, so we are saying this stands for kilo, this is hectare, this is deca, this D is a dec, this is a cent, and then this is a milli. Okay, so every unit is a multiple of 10. There's a 10, there's a 10, a 10, and a 10. So if ever they ask us, how many meters do we have in 1 kilometer? So from kilo up to meter, it's a 10, a 10, a 10, which becomes 1,000 meters in 1 kilometer. If we ask you how many centimeters do we have in a meter? So from the meter to the centimeter, it's just 2 steps, which is 100. Okay, so 1 meter is having an equivalent of 100 centimeters. Then millimeters and the centimeter, which is just 10. So 10 millimeters is 1 centimeter. Okay, so we need to familiarize ourselves with how this conversion works, just as we saw. So the SI unit for the length is meter. So when you go anywhere else, you talk about the meter, anybody sensible will know that, oh, we are measuring length. So the symbol used for this base unit is M, okay, which is small m. Therefore, we write 10 meters as 10 m, not the space between the number as well as the unit. So it's not 10 with that, but there has to be some bit of space. Then the decimal multiples, the cent, the dec, the meter, deca, hectare, kilo, and so on. Okay, so the smallest is the milli. So we have 10 millimeters in 1 centimeter. 1 decimeter is 10 centimeters. So multiples of 10, as we explained. Okay, so the rule is very simple, that when you're converting from a big unit to a small unit, you must multiply. Big to small, multiply. Small to big, you must divide. That is the rule that governs these conversions, okay? So remember the factors. Remember the factors. So distance is a length. Example of units that use distances: kilometers to measure long distances, and then meters to measure medium size, centimeters to measure very small, and millimeters to measure extra small. Okay. An example: how do we convert 2.5 kilometers to centimeters? Okay. So kilo, hecto, okay. Something like that. So from a kilometer to a centimeter, that's gonna be 1, 2, 3, 4, 5, which is like 100,000. It's going to be 2.5 times 100,000. Wanna do it once, which is going to be 2500. This is centimeters. Okay. So what this book is telling us that we can move step by step, move from kilo to meter, multiply by 1,000. And then the answer we get, we change it to centimeter, multiply by 100. And then we get that to 50,000. Okay. Here is an exercise which we can do together. Remember our rule, KHD, MDCM. So from meters to kilometer, meters is a small unit. We are changing it to kilometers, which is a big unit. So we're going to divide by 1,000. So 400 divided by 1,000, which becomes 0.4 kilometers. And you look at B, 18 centimeters to millimeters. So centimeters to millimeters, we sing a big unit to a small unit. So it's going to be 18 times 10, which gives us 180 millimeters. And then when you look at part C, from meters to kilometers, just the same as the first one, you're gonna get 4450 divided by 1,000, which is going to be 4.45 kilometers. And then part D, 5 kilometers to meters. So from a kilometer to meter, we multiply by 1,000. So that's 5 times 1,000, which becomes 5,000 meters. And then 12.4 meters to centimeters. So from meters to centimeters, it's by 100. Ne? So 12.4 times 100, which becomes 1240. But that is centimeters. And then lastly, we have these meters to kilometers. We divide by 1,000. So it's a 5.2463 kilometers. Now, out of the 7 units, okay, out of the 7, in most cases at our level, we are only interested in the, is it 4? We have the kilometer, the meter, the centimeter, and then the millimeter. Meaning that from here to there, that's 1,000. From here to here, that's 100. Then that is a 10. And then we divide, something like that. This is 1,000, that's 100. So if we have arrows in that sort of direction, this is what we shall end up with. Okay, so normally it's these ones. So if you're measuring length, then we shall be talking of M, which is meters. If you're measuring capacity, volume, and things, then this will change to L, which is the liters. And then if we are measuring mass or weight, changes to G, which is the gram. And then the rest just stay the same with the conversion factors and all those things. Okay. Oh, we have G also. We have 8 kilometers to centimeters. So kilometers to centimeters, we say we're gonna, okay, let's just go back. We said kilometers to centimeters. So it's 1,000 and then 100, so it's 100,000. So we're going to say 100,000 A because we are multiplying. FGH, okay, 246 centimeters to meters. It's 246 divided by 100, which is 2.46. And then 246 to kilometers, gonna be 246 divided by 100,000. 1, 2, 3. Then the 2 zeros. 1, 2, 3, 4, 5. Okay, 0.00246 kilometers. And then adding this converted to meters. Okay, the 50 is already in the meters. Let's convert the kilometers to meters first. Okay, so that's gonna be 0.5 times 1,000, which is going to give us 500, which becomes 550 meters. All right, then 4.3, oh, by the way, before we go to 4.3. Remember we said we have two sets of units. We have the metric system that talks about measuring length in meters, volume in liters, and then weight in grams. When you talk of the imperial system, that's a system that is used by the colonizers. And so their units are normally still with the body parts. Okay, we talk of the feet. Okay, that is measurement of distance. You guys might have heard of something like miles. Okay, it's also a measurement of distance. For bigger distances, they use miles. For smaller distances, they can use feet. Okay, but they can also use what we call the inches, and then all the other things. Instead of measuring their weight in grams, they measure their weight in what we call the pounds, which is sometimes known as the LB. Okay, if the weight is so small, we use what we call the ounces, which is the OZ. Okay, and then instead of measuring their volume in liters, you've heard of something called the gallons. Okay, the gallons, and then also pints, and so on and so forth. Okay, they use cups, they use spoons, teaspoons, tablespoons, and name it. Okay, even the temperature, they do their temperatures in degrees Fahrenheit. In metric, it's degrees Celsius. Okay, so 4.3 talks about perimeter. Perimeter C of a figure is the distance around the edge of the boundary of a figure. So the total distance around a shape is what we call the perimeter. So if that is A, B, C, and D. So if we get the length AB plus the length BC plus the length CD plus the length DA, the total we get is known as the perimeter. So regardless of what shape it is, okay, it could be a circle, it could be a square, it could be any other shape. As long as we're looking at the distance around it, that is known as the perimeter. Of course, we know that with a circle, the name changes. It will no longer be called a perimeter, but rather circumference, okay? So to measure the perimeter of a regular figure, we usually make use of some properties of the specific regular figure to simplify calculations. An example, if you have a rectangle, square, triangle, and all of that. So with the rectangles, this is what we know, that the angles are 90. This is a length, which is the same as that length. This is a width, which is the same as that width. Now, sometimes the width is also known as the breadth. Okay, so it's just one and the same thing. So don't be confused. Now, if we want the perimeter, we say we're gonna add up everything. So L plus W plus L plus W, meaning that we have two L's, we have two W's. So this formula is what we use to calculate the perimeter of a rectangle. Okay, so in this case, they are even factorizing, they're taking out what is common, which is the 2. We're left with L plus W. So it's the same thing, whether it is in the factorized format or it's in the raw format, you still get the same answer. Okay, so this is the formula that we are saying we're gonna be using. So to calculate the perimeter, we must add the size on the short side and multiply. And here's an example. Calculate the perimeter of rectangle with a length of 10 and the width of 4. So we say perimeter is twice into length plus that. Or alternatively, you can go the old school, length width, length width. So 10 plus 4, 10 plus 4, which gives us a 28 meters. If you punch it here, it will still be the same thing. So 2 times 14, which is still a 28. Okay, so regardless of which format you use, you must get the same answer. Now remember, with the unit, it must stay the same. If it was meters and meters, the final answer must be meters. We cannot convert, we cannot find the perimeter if the units are different. Units must always be the same. Okay, we have a square. One thing we know about a square is that all the sides must be equal. Okay, so if we need the perimeter, it will be L plus L plus L plus L. How many L's are here? They are 4. So it's as good as getting 4 multiplied by 1. Then we get our answer. Okay. Example, they want the perimeter of a square with sides 7 centimeters. So the perimeter will be 7 plus 7 plus 7 plus 7. Which should give us a 28 centimeters. Alternatively, we said 4L, so 4 times the length of one side, which still gives us 28. Then when it comes to triangles, if we want the perimeter, okay, we just add up everything. So it's P plus Q plus R, which let's call this C for perimeter, not P. So P plus Q plus R, we add up those lengths, and then we get our answer. Example, find the perimeter of a triangle with these 3 sides. So just plus. So 3 plus 5 plus 7 gives you 15, but that is centimeters. Okay, then circles. So one thing we know about a circle is that the perimeter is called circumference. Okay, we highlighted that. And the circle is a perfectly round plane, in which every point on the circumference is equidistant from the center. So center is the middle point of the circle, and in the distance from the circle, distance from the center to the circle is known as the radius. Okay, and then the distance through the center that is touching ends of the circle is known as the diameter. Now, one thing we need to know is that for us to get the diameter, okay, it must be the radius plus another radius, which means it's 2r. So D must be 2r because this is r, that is also r. Meaning that if you're given the diameter and we want to extract the radius, we shall get the diameter and then divide it by 2. Okay, now there's a formula that we normally use if we want to find the circumference. It's normally given as 2 pi radius, or some people just call it pi times d, which is pi d. Okay. Now 2 pi radius, pi is a constant number. Okay. In some books, it's given as 22/7. Okay. When you put 22, let's just say 22/7, you're gonna get a 3,4285 and so on. But lucky for us, even on the calculators, we have that symbol somewhere here by the times 10 to the x. If you press shift and that button, we get the pi. You press the equals, you change it, you get more or less the same thing, as much as the values are not exactly the same, okay? But in our book or in our study guide, our focus is going to be the 22/7. That's what we're going to stick with. So we have an example. They want the circumference of a circle with a radius 2 centimeters. So formula is 2 pi times r. We substitute that. So you're gonna have 2 times 22/7 times 2. Okay, and then when you do that and simplify this, I'm gonna get 44, which is gonna be like 88/7. We punch this in the calculator. Okay, 88/7 gives us 12,57. 12,57 centimeters. Okay, so that is what we end up with as our perimeter, or rather circumference. So in most cases, always look for the radius. Some questions will just give you diameter. You have to take it upon yourself to get the radius of that particular circle. Now, what also might happen is that, remember, this is now a full circle. What if the circle is half? So half circle is sometimes known as a semi-circle. It's not almost a circle. It's just all of the circle, half of the circle. So half of a circle, if you want the perimeter of the circumference, it's just going to be half multiplied by the total circumference, the 2 pi r. If the circle is just a quarter, okay, let's see. If it's a quarter, meaning that the circumference should be a quarter to pi r. So you get the circumference of the full circle and then multiply it by the fraction of the circle we're dealing with. Even if it's 3/4 of a circle, we just have to do the same thing. All right, 4.3.5, we have irregular shapes. These are shapes without definite properties. These are shapes that don't have really anything in common. So what we do here is very simple. You just have to add up everything the way you see it, like all the sides. Okay, so if this is maybe a 7, a 5, a 3, maybe 8, just plus up everything and then get the perimeter of that shape. All right, then we move on to an example. Can you the perimeter of an irregular figure with 2, 4, 5, 6, and 3. So you plus up everything. They're getting 20. Okay, then next, composite. So a composite shape or a composite figure is basically one figure that is made up of two smaller figures. Okay. A figure made up of two smaller figures combined, in that if you choose to break it down, you get two smaller shapes. We have an example. If half of a circle is combined with a square, and then there is a triangle. Okay, so if ever we want the perimeter of this thing, we just look at the perimeter of the outside. And then instead of adding all the four sides of the square, we shall just focus on the two sides because these are the outside ones. The inside ones, we ignore them. So even with a triangle, regardless of where the sides are being shared, we just focus on the outside. It's this, that, and then all those. If the shape is in this format, still focus on this, focus on that. Just whatever you see, the outside or the boundary is what you just add, for as long as you're looking for the perimeter. Okay. So remember, they're telling us it's just the sum of the lengths of all the sides. We have this exercise. Let's try it. Right? Calculate the perimeter of each of the following. There's a rectangle with 1,2 kilometers and 375 meters. Remember what we said? The units have to be the same. This is kilometers, this is meters. So it's either we convert this to kilometers or we convert this to meters. The question is not specifying on which one to use, but I'll take, let's use the meters. So meaning that we need to multiply this by 1,000, which makes it 1.2. So 1.2 meters is the length, and then the breadth is 375 meters. So we said perimeter is twice length plus the width. So 2 multiplied by 1.2 plus 375. That's going to be 2 times 1, 575. Okay, is that 3,000 something? So 1,275 multiplied by 2. So never, it's 1,5, not 1,2. So 1,575 multiplied by 2. So 3,150. Okay, so that is our perimeter. Then a square that is having sides 3 centimeters, we say 4 times 3, which is 12 centimeters. Or 3 plus 3 plus 3 plus 3, we get 12 centimeters. Then part C, if we have a triangle with these 3 sides, millimeter, 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 so we just have to plus up everything. So 30 and 25, that's going to be a 55. 55 plus 15, that's going to be 70 millimeters. Okay, and then next, we have a circle that's having a radius of 4,5. So with a circle, we say circumference is 2 pi radius. So 2 times the 22 over 7 times the 4,5. Okay, let's see. So 2 times 22 over 7 multiplied by the 4,5, we are getting 28,29. Okay, it's approximately 28,29 meters. And then a figure with 4 sides, all of these same units. So 7 and 13 is 20, and then that is going to be a 47. So 47 plus 20, we get 67 meters. Okay, and then question number 2, they want us to get the perimeter of this shape. So this is a composite shape that we need to work with. And we said, break it down if you have to. So one thing we need to know is we need to know the sides. Okay, so if this is a 1, then automatically this must also be a 1. If this is 3, this must also be 3. And then we need to find the top. So we have 2,5, 2,5, that's a 5. And then 5 plus 0,5, which means the top here is 5,5. Okay. Then what we do next? We need now to plus up everything. So our perimeter is going to be the 5,5 plus this 1 plus this 2,5 plus this 3 plus the 0,5 plus the 3 and then plus the 2,5 plus the 1. Okay, let's see if we punch this in the calculator. So 5,5 plus 2,5 plus 3 plus 0,5. I'm adding a 3, I'm adding a 2,5, and then I'm adding a 1. This becomes 18. So we get 18 centimeters as our perimeter. And then question number 3, someone must obtain a quotation to fence this entire property. His plan, or this is the plan of the property, and then we ask you to help him determine the total meters for the fencing. So when they ask for the total meters for the fencing, you're just looking at the distance around the shape, which is more or less the same as the perimeter. So what we know is that this is a 50, this is a 5, meaning that we're going to have this as a 45, because 45 and 5 must give us 50. Then if the whole of this is a 45, okay, that's a 45. But we have this as a 25. We need to find this missing distance, which is going to be 20. Okay, so that is a 20. Let's see. Come to check. We need to plus up now what we found. It's going to be 50 plus the 45 plus the 5 plus the 20, and then plus now this 45 again, and then the 25. So it's 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. Okay. So let's plus up. That's going to be a 50 plus 45 plus 5 plus 20 plus 45 plus 25. Okay, so we're getting 190 meters. Okay, remember, all the units have to be the same. So that is how we do this kind of thing. All right, and then 4.4 is talking about the area. Now, perimeter is the distance around the shape. Area on the other side is just the amount of space that is covered by the shape. Okay, the size of a surface to specify, we calculate the area. So basic unit is the unit squared. The SI is meters squared. If we were calculating using centimeters, then it would be centimeters squared. If it was kilometers, then it is kilometers squared, and so on. Now, for us to get the meters squared, it's like you are multiplying the length look at the rectangles. For us to get the area of the rectangle, it's going to be length times the width. In some small grades, they used to do this. Okay. And then they ask you how many squares are here or how many blocks are here. So when you count, there are 6 blocks. And then that 6 would represent the area of the rectangle. How did they get the 6? We have 3 blocks here. And then we have 2 blocks here. So we just multiply 2 by 3 to give us a 6. So which means that area of the rectangle must be length multiplied by the breadth. So in this case, 5m, 3m, the area must be 5 times 3, which becomes 15 meters, but squared. It needs to be squared since it is the area. Okay, so they are trying to draw the blocks for you and show you how it is done, okay? But we're not gonna draw blocks. We just need to know how to use the formula and carry out the calculations. Okay, so at the end of it all, they are just going down to show you that this is the formula that we always use. Then 4.7, to calculate the area of a rectangle with the size 1,000 meters and 1,000 meters, we just have to do the multiplication with the formula. So 1,000 times 1,000, that's gonna be like 1 million, at 1 million meters squared. So instead of working with 1 million meters squared, we convert this to kilometers, meaning that it is like 1 kilometer times another kilometer, which becomes 1 kilometer squared. This brings out something that I need to also probably highlight right now about the conversions that we just did previously. So remember, if the units are, let's say, kilometer squared, meter squared, centimeter squared, and then millimeter squared, we can do the conversion between these units, whereby instead of multiplying by 1,000, we shall say 1,000 squared. Multiplying by 100 is going to be 100 squared, and then multiplied by 10 squared. And then we're going to divide by 10 squared, divide by 100 squared, and then divide by 1,000 squared, something like that. Okay, if it's units of volume, we still do the same thing. Okay, so what I'm seeing here with this example is that that's what they're trying to show us, okay, and how the conversions work. Now we have this that I'm interested in, the hectare, okay. This hectare is just a measure that is normally used if the distances that you're measuring or if the areas that you're focusing on are very big. This normally works out if you're measuring a piece of land, because that's where we expect to have very big pieces or very big margins. So what we do, a hectare is just the area of a square with 100 meters each. So if we get 100 times 100, we're gonna get 10,000. If the area is 10,000 square meters, then that is 1 hectare. All right, then here is the question. How many hectares are there in 1 square meter? Okay, 1 square kilometer. So 1 kilometer squared, we need to convert this to meters. Okay, and we said from our conversion factor up there that from meters or from kilometer squared to meter squared, it's 1,000 squared. Okay, so that's going to be 1,000 squared, which is 1 million meters squared. So let's divide this by 10,000. Okay, 4 zeros and 4 zeros, which means we're going to have 100 hectares. Okay, so that's 100 hectares. And then 2.2, or question 2, we want the area of a rectangle with a size 24 centimeters by 18 centimeters. Okay, so that's going to be a 24 times 18. Okay, let's see. 24 times 18. This becomes 432. But this is centimeters squared. And then question number 3, calculate the area of this figure. Now with the perimeter, remember what we said. We just focus on the outside, look for missing sides and all of that. Now, when it comes to the area, we need to break it down, okay? Break it down in a sense that we get two shapes. So I have this as my shape A, I have this as my shape B. So with shape A, if the total distance here is 4, okay, but this is a 2, meaning that this must be a 2 to make it complete. If this is a 1, but then the whole of this is a 4, meaning that this is going to be a 3. So that 3 plus 1 becomes a 4. So I'll say that the area of A plus the area of B. So A is going to be a 3 times 2 since it's a rectangle. This is also a rectangle, which is length 4, and then that, so it's going to be 4 times 1. So I'll focus on this and then focus on this open one. So 4 by 1 is 4. So that is 6 plus 4. I get 10 meters squared. That is our area. Okay, and then next. We are talking of squares. So with a square, you just have to multiply the length times length, which gives us something like length squared. So that is the formula for calculating the area. And then if it is triangles, it's a bit more complicated, but we can make it easier by using the gauge. So normally area of a rectangle is given by a half times the base times the height. Where this comes from is if you have a rectangle with this as the base, that has the height. If you divide it by 2, okay, then we're going to have what we call a triangle. This is a triangle, this is also a triangle. So the area of this entire rectangle is B times H. But since we divided it into 2, that's why we multiply by a half. So that's where this formula comes from. Okay, so they're telling us that we need to have what we call the B, which is the base, and then we must have what we call the height. So the height must make 90 degrees with the base. Okay, so they're just trying to break it down and see how we can get all of that into the base and the height and all of that. Okay, we shall look at some examples, but we are trying to derive how the formula is. So I have base and height, just get straight to the point. This is what we do. Okay, so calculate the area of a triangle with this base and this height. So it's going to be a half multiplied by 9,3 multiplied with a 7,6. Punch that in the calculator, you get just around about that value. And then we have this exercise 4.4, calculate the area of the following shaded part. Now, what we can see with the shaded part is that there are two things in it. Whenever you get the area of a shaded part, okay? So area of the shaded part means that you must get the area of the bigger shape, okay, minus the area of the unshaded. So area of the entire figure minus the area of the unshaded. So we are seeing that everything is a triangle here. So for the bigger triangle, it's going to be a half times the base multiplied by the height, which is a half. My base is from here up to there, which is 14, multiplied by the height, which is 6. I'm subtracting a half multiplied by the base from here up to there, which is a 9, multiplied by a 6. So there are two ways to this, but let's see. It's going to be 7 So that's a 42. That's going to be 3, which is a 21, which means our answer is just 21 meters squared. Alternatively, what someone would have done was to look at this distance as a 14 and find the missing one here, if this is a 9. So this is going to be, is it a 5? What is 5 plus 9? It's 14. Yes, it's a 14. And then we just focus on this triangular. Is our answer correct? What's 7 times 6? Well, this is a 27, not a 21. So 42 minus 27, it's 15, okay? So this is 15 meters squared. Okay, so if we look at this triangle that we show, we can say a half times the base times the height, so a half times 5 times 6 by 2, 1 by 2 is a 3, 5 times 3, which is 15. Okay, it should give us more or less the same answer. Okay, then question 2, we have this as a composite shape. Call this shape A, call this shape B. So shape B is a rectangle, but one thing that I'm seeing with shape A, yes, this will be our base, which is a 3. But then the distance from there up to here, this is going to be our height. So if this is a 4, this is a 5,5, what is the difference here? It's going to be 1,5. So the base is a 3, the height is a 1,5. Here, the length is a 4, the width is a 3. So let's get the total area, we plus them together. So area of A plus the area of B. So it's gonna be a half times 3 times 1,5 plus area of a rectangle, we say this length times the width, which is gonna be 4 times 3. So looking at the first part, we're saying 0,5 is a half. We are multiplying it by 3 and then multiplying it by 1,5. This becomes 4 over 9, which is 2,25. And then we are plusing by 12. When you plus that, you're going to get 14,25 meters squared. Okay, so that is how we go about with the composite shape. And then with the circles, area of a circle will be given as the pi times the radius squared. That's for a full circle. If it's half of a circle, then it's going to be a half multiplied by the area of a full circle. Remember, we said pi is a constant, which is 22 over 7. Okay, so I get the area with the radius 3. What are they doing? Pi radius squared, which is 22 over 7 multiplied by 3 times 3. Because 3 squared is 3 times 3. Let's see. 22 over 7. We're multiplying it by 3 times 3, which becomes 28,29. Okay. If we use the pi in the calculator, it's going to be shift and that pi, we are multiplying by 3 squared. That becomes 9 pi, which is 28,27. I think that's what they used. Okay. Then in this exercise, calculate the area of the following circle. So we were given 25. This is the diameter. We need to find the radius. So 25 over 2, which is 12,5. Then area will be pi radius squared, so pi of 12,5 squared. What do we get? Let's use the pi of the calculator also. So pi, open brackets, 12,5. We are squaring that. What do we get? We're getting 490,87. 490,87, this is centimeters squared. All right, then question number 2 is a composite shape that is having a portion of a circle. Okay, so this is a rectangle, but then this is a semicircle. So let me call this A, let me call that B. So we're going to say the area of A plus the area of B. So that's going to be length times width. This is going to be a half times pi radius squared. Okay, so we know that the length is 50. The width is from here up to here, which is a third. That's a half times pi. From here up to here, that's a diameter, which is a third. So we need to get the radius, which is going to be 30 over 2, which becomes 15. So this is 15 squared. So 30 by 50, that's going to be 1.5. And then a half, so say 0.5 times the pi multiplied by the 15 squared. This becomes 353.43. 353.43. And then we plus this up. Okay, I'll say plus the 1.5. So 1853.43. This is going to be millimeters squared. Okay, so that is how that can be worked out. And then 4.5, which is the volume. So volume in words, we normally use what we call the capacity. Now there's a difference between the two in as much as the calculations and the formats mean the same thing. So volume of a shape is how much space that shape takes up. Okay, when you sit in a certain place, the amount of space you take up is known as the volume. Capacity is more like how much content can space take up. Let's say we have an open room, the amount of space within the open room. You have a cup with space inside, how much can be filled up. That's what we call the capacity. So SI is cubic units. Okay, volume of a cube will be length, length, and length. Okay. Now, before even we go to the shapes, for us to get the volume of any shape, you must get the area of the base. You multiply it by the height. This is the standard formula. Base area times the height. If you have a cube, okay, as what the study guide is telling us, that's the length, that's the length, that's the length. The area is going to be length times length, but then the height is also length. So we're going to end up with length cubed. Okay, so for cubes, that's what they're saying. And that's how we arrive at the formula. Now for prisms, we do the same thing. Remember, prisms are named after the base. If the base is a rectangle, then that will be known as a rectangular prism. So you must find the area of the base, which is the length times the breadth, and then you multiply it by the height. This becomes the volume. If it's a cylinder, so cylinders have they have circles at the bottom and at the top. Those are the bases on the top. So area of the base is a circle. So area of the circle is pi radius squared. And then you multiply it by the height, which is h. So this becomes the volume. And then, okay, that is all. And then conversions with liters. So more or less the same thing. We are saying that 1 cubic centimeter is the same as 1,000 cubic millimeters. 1 cubic centimeter is 1,000 cubic millimeters. Okay, then we also need to know about the 1 meter cubed is the same as 1 million centimeter cubed. And then we also need to know that 1 liter is an equivalent of 1,000 cubic centimeters. Okay, I think that's what they are highlighting also here. All right, so we skip that, skip the conversion, and then example, determine the volume of a cube with sides 50 millimeters long. You must give the answer in cubic centimeter. So it's up to you. You can choose to convert at that same point, okay? And then that's gonna be millimeters to centimeters, you divide by 10, so it's gonna be a 5 centimeter. So volume, we say this length times length times length. So 5 times 5 times 5, which gives us 125, but this is centimeters cubed. Alternatively, if you have kilometers cubed, no, it cannot be kilometers cubed because we are measuring liters. So it's going to be kiloliters cubed. We're going to have the liters. That's fine. Let's do this. Let's do this. Kiloliters, centiliters, and then milliliters. So from the kilo to liters, you're going to multiply by 1,000 cubed, and then by 100 cubed, and then by, I think I messed it up. Divide by 10 cubed, divide by, I think I've messed this up. Let's say it's some kiloliter cubed. I think when I put the cube, then it's gonna make more sense. And then divide by 1,000 cubed. Okay, so it's the same as kilometer cubed, meters cubed, centimeters cubed, millimeters cubed. When you do the conversion, we just have to express it with exponent 3. So looking at this, if we had multiplied this 50, 50, 50, we'll get 125,000. And then from millimeters to centimeters, okay, millimeters to centimeters. I don't know why I chose this here. Then we divide by 10 cubed. 10 cubed is like 1,000. So you divide by 10, divide by 10, divide by 10. The 3 zeros fall off. You'll be left with 125. Okay, then determine the volume of a prism with these measurements. So volume, length, breadth, and height. 2 by 3 by 3, which is 18 meters cubed. Okay. Do they want the answer in liters or give the answer in liters? So we know that 1 meter cubed is the same as 1,000 liters. So just multiply this by 1,000, which becomes 18,000 liters. And then at 3, determine the volume of a water pipe, which is 2 kilometers long with a radius of 25 centimeters. Give the answer in liters. So we need to change everything to the same units. I would rather change the 2 kilometers to centimeters. It's going to be 2 times 100,000, which becomes 200,000 centimeters. So a pipe is in a shape of a cylinder, meaning that I'll have my pi radius squared height. So pi, they gave us the radius of 25, so 25 squared. We are multiplying by the height or the length, which is 200,000. Let's see. So pi multiplied by 25 squared, multiplied by 200,000. Okay. So we are getting 3926. Okay, 3926, 99081, 99081, comma 7. So this is going to be in centimeters cubed. But we know that 1 liter is 1,000 cubic centimeters. So we need to divide this by 1,000. Okay, so when I divide it by 1,000, I'll get 392699,08 liters. Okay, so that is what I'm getting. They say they want it to be rounded off. No, it's not a big deal, but that is that. Okay, then 4.6. How many cubic centimeters are there in half a liter? So we know that 1 liter is 1,000 cubic centimeters. Now, when you talk of half of a liter, you're going to half this as well, which will be 500 cubic centimeters. Then the perpendicular height of a circular dam is 1,5, and the diameter of the dam is 5 meters. So when you talk of a dam, it takes the shape of a cylinder. Okay, so the height is 1,5, the diameter is 5. They want us to get the volume in liters. So volume, we need the radius. So 5 divided by 2, which is 2.5 meters. So volume, we're saying pi radius squared height. So pi, the radius is 2.5 squared multiplied by 1.5. We substitute. So that is pi into 2.5 squared multiplied by 1.5. That gives us 29.45 24. This is going to be centimeters cubed. No, this is going to be meters cubed. But we said that 1 meter cubed is equivalent to 1,000 liters. So multiply this by 1,000, which is going to be 29452.4 liters. And then 3, they want the volume of a prism that's measuring this. Okay, so it's going to be 12 by 9 by 4. 12 by 9 by 4. That gives me 432 centimeters cubed. All right, so that is how we would have gone about this. And then the summary of this unit, that is the formulas. And then the applications. Okay, let's look at some applications and then we close off this topic. Okay, so we have mastered the basics of measurements. So we need to apply the problems that I encountered. Okay, example number 1. You need to tile your lounge floor that is measuring 5 meters by 2.5. How many tiles will be needed to tile? If the tiles are 250 by 250, you must add 10% for breakage. So step number 1, you need to get the area that needs to be tiled, which is 5 multiplied by 2.5. This gives us 12.5 meters squared. Then you also need to get the area of one tile. Remember, tile is always a square. Let's convert this to meters. 1, 2, 3, which is 0.25 multiplied by 0.25. The units have to be the same. Okay, so we're saying area of the tile is going to be 0.25 times 0.25. That is 625 is 0.0625. Is that correct? It's not making sense. 0.025, yes. So 0.0625 meters squared. Because I got it here 0.25 applied to 0.25. 0.0625. And then from there, we need to divide this area divided by that. So area of the floor divided by area of the tile. So 12.5 over 0.0625. Let's see. That gives us 200. So we're going to need 200 tiles. But they told us we must account for the 10%. So 10 over 100 gives us 20 tiles. So in total, we're going to need 200 plus the 20, so that we end up with the 220 tiles. Okay, so that's what they have, and then that's what they get. All right, so we have another context. How much will it cost to fill the swimming pool to the brim if the pool is in the form of a prism 6 by 6 by 2? And then you buy water 5 rand per kiloliter. So we need to get the volume of the pool, which is 6 by 4 by 2, which is 48, but this is meters cubed. If we convert this to liters, we need to multiply by 1,000 to give us, I know we don't need to, because they gave us in kiloliters, so which means it's the same as 48 kiloliter, cost times 1,000. Then multiply this by 5. So 48 multiplied by 5, that's going to be 240. So you're going to pay 240 rands just to fill up that pool. Okay, then question 1. You want to cover the walls of your bedroom with the wallpaper. The bedroom is 4 by this, and then the walls are that high. One roll paper covers this much. How many rolls will you need? Ignore the doors and the windows. Okay, it's fine. Or a rectangular room with everything intact. Okay. Okay, so meaning that we're going to have the 4,3 2 times. It's going to be 4,3. I'm multiplying it by 2,5. And then I'm going to have the 3,4 multiplied by 2,5. So this is one wall. That's also one wall. Okay, let's see. So 4,3 multiplied by 2,5 gives me 11,25. And then 3,4 multiplied by 2,5, that becomes 8,5. But now this is one wall, that's one wall. In a room, there has to be four walls. So you can plus this and then multiply by 2. Yeah, so 11,25 and 8,5 gives me 19,75. Multiply this by 2. What does that become? So 19,75 times 2, that becomes 39,5. This is meters squared. Can multiply this by 2, multiply this by 2, and then you plus up. We should get the same thing. So this is the area that needs to be covered. Now, if one roll covers 4,5, we're going to say that the number of rolls, get the area that needs to be covered divided by the area that one roll can cover. So 39,5, we are dividing it by 4,5. That gives me 8,777, 8,7 recurring rolls. So we need to buy full rolls, not fractions. So this is approximately 9 rolls. Buy the 9 rolls, we cut off what we don't need and use whatever is needed. Okay, then question 2, you've moved on and into a newly built house, and then you want to cover the whole garden with grass initially. The budget is 15,000, and then the figure shows the area you want to cover with grass. The garden contractor has quoted you 15 rands per square meter to plant this type of grass, and then 20 rand per this to plant the LM grass. Will you be able to use this contractor or stay within your budget? Okay, so grass must be all over. We know that the house is not going to be grass, the paving won't be grass, the pool won't be grassed. So to get the area that needs to be grassed, we need to start by calculating the area of the entire plot of land. Okay, so area of the land is going to be 30 by 40, which is 1.2 meters squared. And then we need to subtract the area of the house and all of that. So this brings in a complex scenario whereby we need to look for the area of these individual shapes. Let's break it up into this kind of format. Okay, so I'm going to look at the paving and the house just in the same sort of format. Okay, I don't know what number is this. Is it a 15? I don't know. If that's a 10, it's going to be a 5. Okay, that's a 10. Okay, which means that all of this is 15. Okay, so let's see. If this is A, this is B, that is C. So I'll say area of A. Since it's a rectangle, it's going to be 15 and 10 is 25. I'm multiplying it by the distance here, which is 5. This should give us what's 25 times 5 is 1.5. It should be, yes, 1.5, okay. And then when you look at the B part, if we removed this 5 here, it's going to be a 10 by 10. So area of B is it's going to be 10 by 10, which is 100. And then area of the pool, it's going to be 6 by 4, which is a 24. So when I plus up all that, it's 100, that's going to be 225 plus 24, it's going to be 249. Then I need to subtract it from there. So area to be grassed is 1.2 minus 249. We get 951. Okay, so 951 meters squared. Now let's go to the comparison of the budget and stuff. So one, they're telling us that you have to pay 15 Rand per square meter for the Kikuyu grass. So 15 multiplied by the area 951, let's say 15 times 951, that's 14 to 65, 14 to 65 rands. And then for that other type of grass, 20 by 951, that becomes 1920. So 19,020 rands. So we can see that the Kikuyu grass is cheaper and more affordable. Will you be able to use this contract and stay within the budget? So the answer is yes, you can stay in the budget by using the Kikuyu grass because you're gonna pay less than what you budgeted for. All right, guys, so we're going to stop there for this chapter. Thank you very much. Let's meet in the next episode when we talk about the equations and formulas. Bye-bye.